In this problem, we are given the following circuit diagram here, and we're told to use the mesh current method to find the following currents. It asks us to use the mesh current method. However, when I look at this, in doing the mesh current method, we're going to have to analyze the current flowing through this part, the current flowing through this part, and this part, and a little bit of this part as well. And that's 4 different things we have to do. Instead, what I'm going to use is the node voltage method and analyze the node right here and look at all the currents going into it and then find our voltage over the I of D. And then we can put the voltage over I of D over the 5 ohm resistor to find our current, and then use this to find the other currents as well. To start this off, we see that we are going into the positive, out of the negative here. So when we look at this, we're going to have to draw a plus minus V, and we'll call this VD. And we're going to do a VD minus the source voltage, which is 100, 0 degrees. However, I'm going to convert this into rectangular form because we have some J's and that can be quite confusing. To convert something to a rectangular form, all we need to do is have the number and then in parentheses cosine of our angle plus J times the sine of our angle. And if we do this for the first one, we are going to have 100. And 0J, so we're just not going to include J, and this is all happening over the J 5 ohm impedance. Next we're going to have the VD over our 5 ohm resistor. Next we have this other voltage to the right side. We can see that it's going this way, into the positive, out of the negative. So we're going to have a plus VD, since it's going in the opposite direction, minus a negative 50. And this is over our negative J5. This is all going to be set equal to 0, and this is going to be our equation. What I'm going to do from here is multiply everything by J5 so that we can get rid of it on the denominator. This is going to give us a VD minus 100 plus a JVD, and then we will have a minus VD minus 50, and this is all equal to 0. Now we are going to add some of these together and cancel things out. This VD and this negative VD are going to cancel out. We can move our constants to the right and then divide both sides by J again. We're going to get VD is equal to 150 over J. We know we can bring the J into our numerator by making it a negative, so we're going to have negative J 150. And this is going to be the answer for our VD. Now we are going to solve for our I of D. We're going to use Ohm's law and set our I of D equal to the voltage of D over the resistance at D. So we can plug in our values. We have negative J 150, and then we also have our 50 ohms of resistance. And this is going to turn out to be a negative J 30. Now we need to convert our negative J 30 from this rectangular form into our polar form, because that's what it's asking for us right here. We need to find the magnitude and the theta. To find magnitude and theta, we are going to use the formula that Vm is equal to the square root of our real number squared plus our imaginary number squared. And that's going to be our first number, and to find our theta, it's going to be equal to tangent negative 1 of our imaginary number over our real number. When we plug these in, we are going to get that our first value is 30, and then for our second value, we have a slight problem here. We don't have a real number, or we do, but if we were to write this out, it would be that our I of D is equal to 0 minus J of 30. So our real number is 0, and tangent doesn't touch 0. However, we did not do anything wrong here. Instead, our number is just super small. So when you plug this into a calculator, it's going to be tangent negative 1 with a negative 30 divided by some super small number. So I'm just going to put in 0.000000, just, I don't know, like 27 zeros, and then just 1. I'm just kidding. Only 3 or 4 zeros should be fine. And if you do that, you will get a negative 90 degrees approximately. So this is going to be our I of D. Now we are going to look at our I of B. So we already found our I of D, and our I of B is right next to it, so we're going to solve for that. For our I of B, we can say that our I of B is equal to our initial voltage, which is the 100 with 0 degrees, or 100, minus our VD. And we know that our VD is this value right here. We just found it. So we're going to plug this in. We're going to have a negative J 150, and this is all happening over the J5. So now we can add these together and kind of divide things. If we do this, we're going to get that our I of B is equal to, and then first thing I'm going to deal with is this J150. We're going to make these two negatives into a positive, so it's going to be a plus J150. We're going to divide out the J's, so we're just 150 over 5, and then we're going to be left with 30. So our I of B is 30. Now we're going to have the 150 divided by J5, and this is going to give us 20 over J. And to bring J up top, we know we can make it a negative J, so we're going to have negative J, 20, and this is going to be the value for I of B. However, that is in rectangular form, and again, we need it in polar form. So we are going to convert this using the same formulas that we did down here. If we do that, we're going to get that our I of B is equal to approximately 36 with the angle of negative 34 degrees. Now we're going to solve for IC in the same manner. We're going to set IC equal to the source voltage, which in this case is our VD, because our IC is right here, VD is right here, and then our last voltage is right here. So we're going to have a negative J150, remember we found this earlier, and this is going to be over the negative J5, because this is happening over this impedance. Next, we are going to have our 50 with 0 degrees, and we can see that it's going in the opposite direction, so even though we have our minus, it's going to be a negative 50 with 0 degrees, and if we convert this to the rectangular form, it's just going to be 50. Now what I'm going to do is make this a positive and divide things out. First thing I'm going to do is tackle the first one. We can see that our J's are going to cancel out, and this is going to give us an IC is equal to 30. Now we look at the next part, we have 50 over negative J5. If we bring the J up top, we're going to make it a negative J, so this will become a positive. And then if we divide our 50 by 5, it's going to give us a 10. So we're going to have plus J10, and that's our rectangular form for part C. We need this to be in polar form again, so we are going to plug it into these equations to get our Vm and our theta. And that's going to give us an answer of 32 with an angle of 18.4 degrees. Now we are going to solve for I of A. Initially, when we look at our I of A right here, we can think that our current is going to be this current flowing through it. However, that would be untrue. And we know it's untrue because if we look at these voltages, we can see that it's going to affect this. Because when our voltage flows through here, it's going to be in parallel with this part. So we have some voltage going this way, and we have voltage going this way, and it's going to be the same voltage because these are in parallel. And the same thing for this part right here. We're going to have voltage going in this way and this way. So again, it's in parallel. But since it's in parallel, we know that we can write the formula that we've done previously, that our I of A is equal to the source voltage, which we know to be 100 with our angle of 0 degrees, or just 100, minus, and then since it's going in the opposite direction, a negative 50, and this is all over the 5 ohm resistor. If we add these together, we're going to get that our I of A is equal to 150 over 5, or just 30. And from here, we are going to convert this into our rectangular form. So we're going to do the square root of 30 plus 0. This is just going to give us that our I of A is equal to 30. And then when we plug it into our tangent, we're going to have tangent negative 1 of 0 divided by 30. And this is going to give us the angle of 0. So when we plug this into our I of A, we're going to have a 30 and 0 degrees. And that is how you would go about solving this problem. If you have any questions about this or any of the material covered, you can leave them in the comments below. If you want more introduction to circuit analysis, there's a playlist with over 100 problems in the description below, as well as notes that go over the entire coursework for this class.